So you have to solve this problem using Kirchoff's current law or voltage law, anything you wish. Now let us solve this by using KVL. Let us solve this by using KVL. Okay. So in KVL, first take two loop currents. This is one loop current, capital I1. Sorry, they have used capital I1. So let me use small I1 is the loop current. And this is second loop current, small I2. So what is the relation between, first step is to find out the relation between the loop currents and the branch currents. So you see that this loop current I1 is in the same direction as I2. This loop current I1 is in the same direction as I2 and is equal to I2. So I1 is equal to capital I2. Now come here for small I2. Small I2 is same as that of capital I1. So small I2 is equal to capital I1. Small I2 is equal to capital I1. And now in case of capital I3, this capital I3 is the summation of these two loop currents, capital I1 and I2. Since they are in the same direction as I3, so capital I3 is the sum of small I1 plus I2. Small I1 plus small I2, that is equal to capital I. Now the second step is to mark the voltage drops. Since current is going from in this direction, so your this one is positive and this potential, this part is negative. Current is flowing from up to down, so this is plus and this is negative. Current is flowing from down to up, so this is plus, this is negative. Now write the values of these voltage drops or voltage rises. So it is 3 into I2. 3 into I2. The value is 3 into I2 according to Ohm's law. The branch current is I capital I2 and the resistance is 3. So the potential drop or the potential rise, whichever it may be, is 3 into I2. And in this case, it is 2 ohm into I3. So it is 2 I3. 2 I3. And the value of this is 5 into I1. Value of this is 5. Right. This is the second step. Now the third step, we will apply Kirchoff's current law, Kirchoff's voltage law in this loop, this first loop, in which small I1 is flowing. So in this loop, we will start our journey from this point. From this point, we will start our journey, and first we will encounter this voltage source. We are encountering this voltage source. It is a voltage rise. So according to Kirchoff's current voltage law, all voltage rise, sum of voltage rise is equal to sum of voltage drop. What is the voltage drop here? 6. Voltage drop is 6. Voltage rise is 6. My mistake. Voltage rise is 6. Now next you encounter this resistance. This is plus, this is negative. So you encounter a voltage drop. And what is the value of this voltage drop? 3 capital I2. So this voltage drop is 3 capital I2. Right? And now you come to this loop. You have encountered this loop and you are coming here. Now when you are coming here, you encounter this resistance. And this is also, this was plus and this is negative. So you encountered a voltage drop in crossing this resistance. When you are encountering a voltage drop, it means it should be added here. So and the value is 2 into I. Value is 2 into I. And finally, you reach this starting point. So your loop has been encountered once. So this is equal to voltage rise is equal to sum of voltage drops, or sum of voltage rise is equal to sum of voltage drop. Now you see, these are the branch currents. You cannot write a loop equation or a mesh equation with the branch currents. You have to convert them into loop currents. So instead of capital 3I2, you will write 3I1, and instead of 2I3, you will write 2 small I1 plus 2 small I2. And finally, your equation is 5I1 plus 2 small I2. This is your first equation. This is your equation 1. Now come to the second loop. In the second loop, the loop current is flowing like this, right? So you will start again your journey from this point, and you reach here. You encounter a voltage source, negative, positive. So after crossing this voltage source, you feel a voltage rise. So again a voltage rise 12. After crossing this voltage source, you encounter this resistance. This is a voltage drop. This was plus, this was negative. So let me write it here. 5 and the value is 5I1, capital I1. After encountering this resistance, you come here again and you encounter this resistance. And this is positive, upper side is positive, lower side is negative. So again, it is a voltage drop. So the plus sign in the voltage drop side value is 2I. Again, these are the branch currents. You have to convert them into loop currents. 5 capital I2. Capital I2 is I1 minus 5 I1. I1 is I2, sorry, small I2. And plus 2I3, capital I3 means small I1 plus small I2. And your equation is 2I1 plus I1 plus 7I2. So 12 is equal to 2I1 plus 7I2. This is your equation 2. This was equation 1, this is equation 2. So now if you solve these two equations, right? If you solve these two equations, you will get the result small I1 and small I2. So solving this, you will get small I1 is equal to, solving this, you will get small I1 is equal to 0.58 ampere and small I2 is equal to 1.55 ampere. Right? But you need to find out capital I1, I2 and I3. So capital I1, I2 and I3, capital I1 will be equal to small I2 which is equal to 1.55 ampere. Capital I2 will be equal to small I1 which is equal to 0.58 ampere, and capital I3 will be equal to I1 plus I2 which will be equal to 1.55 plus 0.58 which is equal to 2.13 ampere.